You are watching for the greater good.
Today, we will learn about the minimization of expression using Boolean Algebra, standard canonical forms, sum of products and product of sums, minimization using Karnaugh map. Let's start. In front of you, there are some laws which are very important. You need to memorize them, especially the associative and the absorption law. Here is an example of simplification of Boolean expression using previous laws. I hope it's easy to understand. Logical expressions can be written in two forms, SOP and POS, which are sum of products and product of sums, where all product terms are added, and product of sums are where all sum terms are multiplied. For SOP or POS to be standard, they should involve all variables in each term. Third expression shows that it's not standard as does not contain C or C bar. Each product term of standard expression is called min term, whereas each product term of standard expression is called max terms when you are talking about the product of sum. For SOP, A is equals to 0 is denoted by A bar and A is equals to 1 is denoted by A. But in product of sum, which is POS, A is equals to 1 is denoted by A bar and A is equals to 0 is denoted by A. Here you see the truth table with min terms and max terms expressions. First equation denotes the sum of products, and where output is 1, we have written min terms, decimal value and expressions to the previous slide. Refer previous slide for it. Second equation denotes product of sums, and we have done the same using for it. Now, we will convert the given expression to standard sum of product. This is not standard as first term does not contain C or C bar, and last term does not contain A and A bar. So we will add C plus C bar and A plus A bar, simplify it. Sum goes to the product of sums. This time we will add C and C bar and A bar. Here is an example of 3 input variables with 8 cells and 4 input variables with 16 cells. Note that the adjacent blocks are changing by 1 bit, and first and last block both vertically and horizontally is changing by 1 bit. When moving from one cell to the next along any row or number one cell to the next along any column, one and only one variable in the product term changes. Grouping in Karnaugh map be like encircle group of adjacent ones, not diagonal. Size of group should be power of 2, like 1, 2, 4, 8, 16, or maybe 32. Form the largest possible group. For example, if you're having a quad, or you are supposed to make a quad rather than making a pairs of it. So always try to make the largest possible group. Rightmost and leftmost cells are considered adjacent. Uppermost and lowermost cells are considered adjacent. Least number of groups should cover all ones. Groups may overlap. At least a single one should be unique in every group. Note the note changing variables in each group. If octet group forms three variables will be removed from term. If quad group form the two variables will be removed from term. If pair, then a group of one variable will be removed from term. If no groups form, then we will write all variables as it is.
Hello, here we have two examples, one for SOP and one for POS. In SOP, here we have a Karnaugh map of 3 input, so 8 cells to on total. We place the ones in the position 0, 2, 3, 7. The 0, 2, 3, 7 are the decimal value. You can compare the binary value from here. The empty cells are 0. So before grouping, we learned some rules. So first check whether an octet is present. An octet is a group of 8 ones. Then check for a chord. It is a group of 4 ones. Then check for a pair. So we cannot find 8 ones and 4 ones. So we'll go for a pair. We can see 2 pairs over here. So we'll highlight them. One is this one, and the other is this one. As you can as you can see in the rule book, the rightmost and the leftmost bit are adjacent because they are changing by only 1. So that is why we have made a pair. After making a pair, we'll note the non-changing variables. The non-changing variables in this pair are y and z. So we noted y and z over here. And in this, our x bar and z bar are non-changing, so we noted them here. This is the final minimized equation. This same goes for POS. In POS, it is vice versa, as a bar is denoted by 1 and a is denoted by 0. So here also, the empty cells are 1, and we made a pair over here and over here, and the final equation comes to be y plus z bar x bar plus z, because these are the non-changing variable in this. As you can see, y and z bar, y is denoted by 0, z bar denoted by 1, and in this over here, x bar plus z are non-changing. So let's move to next slide. For where is So in this example, we'll follow the same rules. We'll see for an octet, then for a chord, then for a pair. Over here we can see one pair over here, and as this one is unique, this can form pair with this. We are left with this one. Note that pairs cannot be formed diagonally. So we noted this one. Now we'll note the non-changing variables. Here in this part, C and D are non-changing. So C bar, D bar, and A is also non-changing. So A bar, C bar, D bar. In this pair, A and B are non-changing. So A bar, B bar. And finally D is also not changing, to we noted D bar. Remember that if you get a pair, so pair is 2 to the power 1 is equal to 2. So the one denotes how many variables will be removed. So one variable will be removed. For an octet, 2 to the power 3 is equal to 8, so 3 variables will be removed. Here in these two equations terms, one variable is removed. Finally, this single one will write as it is all the terms. So A bar B C D, A bar B C D. So this is the final minimized equation. Let's go over here. Here we'll check for an octet. We cannot group 8 ones, so we'll check for a chord. We can make a chord like this. And also we can make a chord like this. So in total we get 2 chords. Chord is 2 to the power 2 is equal to 4. So in reality, two variables will be decreased from the terms. So here AD dash plus CD. Here CD are non-changing, and over here A and D complement are non-changing. So we noted it down, and as you can see that two variables are missing. So this denotes that these both are chord. Moving to the next. So now we'll follow the same rules. Over here, first we'll check for octet. Octet is a group of 8. We cannot find a group of 8. So we'll go for a chord. We can make a chord. We can make many chords. So I will go from this. This is one chord. This is one chord. And this is one chord. finally we are left with 2 ones. So we can make a pair as the topmost and the downmost are adjacent, they are only changing by 1 bit. So we get 3 octet and a pair. So the final terms will contain in 3 chords they will reduce to 2 variables will be reduced, and in the pair 1 variable will be reduced. Moving forward, so this is a 5 variable K-map. 5 variable K-map is simply, it is a paper fold technique, like these two are adjacent. So when we write this, so this is 0 1 2 3 4 5 6 7. Note that it goes in reverse. Here C value of C is same 0 0 0 0 and value of C over here is 1 1 1 1, but these values are reversed. Here 0 0 will come from here, then 0 1, then 1 1, then 1 0. So we'll fill it like this way: 8 9 10 11 12 13 14 15 16 17 18 then from here 20 21 22 23, then we'll start from here 24 25 26 27 28 29 30 31. As we can see that these two cells are adjacent, so if we fold it like a paper, they will be adjacent. Now we will make groupings in this 5 variable K-map. So here we got an octet because these are adjacent. When you fold it like a paper, they are adjacent as they are only changing by 1 bit. Over here you can see 0 1 1 1 1 1, 0 0 1 1 0 1. So we get an octet over here with 8 ones, and then we get 2 chord. Here is 1 chord and here is 1 chord. So we'll get a final equation which will be BE plus A complement B complement E complement plus A D complement E complement. As we can see, this is an octet, so 3 variables are reduced. 2 to the power 3 is equal to 8, so 3 variables are reduced. These 2 are chords, so 2 variables are reduced from my equation of 5 input. Moving towards next. So this is, I think, the final practice question. Here we'll use the same strategy. Here we can see this is a pair, and we can see that this is a pair, and this is also a pair, and this is also a pair. So total we got 4 pairs, and finally you can see this one is adjacent with this one, because here 0 1 1 and 1 1 1, the bits are changing by 1. So they, by according to paperfold, they both are adjacent, so we can make them a pair. So in total we get 5 pairs. So our final equation will be A, B, C, D plus A, B, C, E plus A, B, D, E plus B, C, D, E. Plus A, C, D, E. As you can see that they all are pairs, so 2 to the power 1 is equal to 2, and the power denotes that only one variable will be true. So you can see only one variable is removed from all the terms. So I hope you enjoyed this video, and stay tuned for more videos. Thank you.